Thank you for joining me. This is Bill Gray. I'm with Washington State University, the Engineering and Technology Management Program, Master's Degree Program. And I'd like to talk to you a little bit about the system engineering courses that we teach as part of the program, and also the certificate program that we have available through enrollment through the METM program. I want to discuss a couple of topics here. First of all, I'd like to talk to you a little bit about what system engineering actually is and why it's important, and some of the project management activities that are associated with systems engineering, and then a little bit more about the certificate that we have at the WSU ETM program as part of the program activities. So the first thing was, what is system engineering? And I've taken some of the inputs from the site from INCOSE, which is the International Congress on Systems Engineering, and it emphasizes that system engineering is an interdisciplinary approach, and it is a means to enable the realization of successful systems. It focuses on defining the needs of the customer and also the functionality early in the development cycle, and documenting those requirements and then proceeding with the design activities. Later on, there's the validation of the activities that take place in the design through test and analysis, and also working in the field with the particular system. It's a well-developed body of knowledge, and it's been tested through several programs through the military as well as the commercial sector for programs that were funded by military as well as commercial entities. And its general use is really in the area where we have complex technical activities, complex problems as far as interdisciplinary contacts throughout the project. Its goal is really efficient production and high-quality products that meet the production of the customer. The aspects of the process, from the initial definition of the mission requirements to the test, verification, and fabrication of the product, they have to be carefully planned and executed. So system engineering really integrates all these disciplines and the specialty groups into a team effort that forms a structured development process that proceeds from the concept of the particular product to the production, into operation, and then finally into the disposal of the particular program. The system engineering considers both the business and the technical needs, and it includes the operations, the performance, the test, the manufacturing, the cost and schedule, training and support, and disposal. Okay, so what is or why is systems engineering important? About 35 years ago, there was some Air Force work that was being conducted by the Ballistic Missile Division, which was located in Los Angeles. And they were having schedule problems as well as budget problems, cost problems coming to some of their systems, bringing them into realization. And so they started formulating a concept which later became evident as the systems engineering process, and which is shown on this particular chart, where you start from the beginning, where you have the concept refinement, you go into technology development, you go into the systems development, and then into the production and deployment, and then operations and support, and then finally for disposal of the particular system. And there's a number of things that can happen during this particular process. They've interjected various points along this particular process that includes reviews of where they're at, and reviews that allow them to meet their needs and then go on to the next part of the process. The thing that's important here is that during these particular times, there's quite a bit of expenditures early on in the program. You'll notice from the chart that up until the midway into the production part of the program, you spend about 28% of your funds in for the life cycle costs, and for the remaining part, about 72% in the production, operations, and support, and then the retirement portion of it. So it's very important that systems engineering and the integration of all these disciplines takes place early in the program, And the architecture needs to be put together such that you come up with a viable system in the end and not have schedule impacts and cost impacts, as was the case early on in the programs that the Air Force was working. There's some recent information as early as year 2000, 2004 that shows that we still need to employ more system engineering in some of our activities. And system engineering management is a very important part of that. If you look at the next chart we have here, it's why is system engineering important? There's a commitment to the life cycle, and you can see here the design changes early in the program really have a great impact on reducing the cost and life cycle costs of the program. Whereas you go later out in the program through system utilization and sustaining support, the ease of a change to a program is very difficult to make and is very expensive to do. So it's important that all these activities, which system engineering is a very important part of, take place early in the program cycle so that the end product is viable and it meets the customer needs. Okay, so what does the system engineer do? So if you look at the system engineer in relation to a project manager, the system engineer really needs the identification and customer linkage. And these needs are those that the customer has wanted as far as in the new product that we're trying to develop, or the software it could be also. Then there's the requirements engineering. The system engineer puts together all the requirements based on these needs and then allocates those functionally down to the lowest level in the statement of work, and then the requirements engineering part of it is done clear down to the functional architecture at the lowest level, so we can go ahead then and support it with supplier functions to procure the equipment needed to assemble the product. Then there's the operational concept that the systems engineer puts together, the architectural design. They work on the analysis, development, and testing to verify that the product actually meets the customer needs. They do trade-off analyses, and trade-off analyses are part of the activities that are included to try to make sure that the optimum design, considering cost and all the constraints and the schedule, are all met with the best product that can be had based on those particular activities. Then they integrate. Their integration part of it is to make sure that all the LOTs, including mechanical engineering, civil engineering, safety engineering, all of those are included as part of the system engineering effort, so that everyone has a part in making the decisions and also a part in performing the analysis and the design activities that are required for the product. Then they also have a part in system performance, making sure that the system itself performs as it should and meets the customer requirements, and they demonstrate that also for the customer. Now, the project manager is one that oversees all of this. Of course, the project manager is the leader of the project, and he has many, or she has many activities and many organizations under them, so that system engineering is just one of those, although it is a major part, particularly early in the program. And the project manager also works with interface liaison, the project control system. They control the activities as far as the risks management and so on. They provide direction, and the program manager actually is a product leader, and he provides direction to all of the other organizations below him. And based on the project manager work and the systems engineering manager, the successful projects really have the technical leadership of the systems engineering manager and the management guidance from the product manager. It's important to have all of these in tune together to come up with a successful program at the end. So if you'd like some additional information shown here on the next slide, your complete application procedures are located at the website for the Engineering and Technology Management Program. and that's shown here as the website. There's a WSU graduate school website that you can obtain the materials to enroll in the graduate school. And for more information on the whole ETM program and also the certificate, you might want to contact Patty El-Shafi, and her phone numbers are given there. Also, I am the instructor who teaches the system engineering courses, and my name and William Gray, Bill Gray for short, and my phone number is shown there. I'm also the Washington West Coast focal point for the program. So if you have any questions really about the program, if you're on the west side particularly, I'd be happy to meet with you. I do visit major companies on the west coast from time to time, and usually try to announce that to the existing students or through a newsletter that's sent out. So hopefully if you have any questions about the program or the information here, please give me a call or an email. And you'll find my email is wgray@wsu.edu, which is really pretty easy to follow. And if any luck gets through, it'll get to me on my email site. Thank you.